Now we will discuss about some concepts regarding atomic radius and ionic radius. So cations having lesser number of electrons experiences higher electrostatic attraction, giving lesser radius compared to its elemental form. So let's see, we have these elements here in the elemental form: lithium, sodium, potassium, beryllium, magnesium, calcium, and in this side we have fluorine, chlorine, bromine, iodine. Now these atoms, here we have similar number of protons and same number of electrons. So number of proton and electrons are same, but when we take out an electron, in that case number of proton is more and number of electron is less. So that time we get cations. These are the cations. And when we put an extra electron in this elemental form, so that time we have lesser number of protons and we have more number of electrons. So that time we get anions. So these right hand side ones are the anions. Now it is saying that cations having lesser number of electrons, because we have already removed one or more electron, right? So in this case we have removed one electrons from lithium, sodium and potassium. So it has now less number of electron, one less electron. In sodium we had 11 protons and 11 neutrons, sorry, 11 protons and 11 electrons. Now we have removed one, so now we have 11 protons and 10 electrons. So we have less number of electrons, and that experiences higher electrostatic attraction, because now we are removing one electron, so one lover is removed. So now the nucleus or the attractive girl, that can give more love to each electrons, right? So that can give more time or more attraction. So that's why the electrons feel more attraction now. Just I will try to clear this concept here. See, this is my nucleus and these are the shells. Let's see in case of sodium. In case of sodium, we have 2 electrons here in the first shell. Then we have 8 electrons in the next shell, and we have 1 electron in the last shell. So this one is in the last shell, right? Now what happens when we remove this electron? If we just remove this electron, we take it out, so sodium becomes sodium plus, and in that case this orbit is completely empty. This third orbit, it had only one electron, right now it is 0. So you can see only these two orbits are there now in Na plus, sodium plus. So obviously the number of orbit is less. And even if you take magnesium, so in magnesium there were 2 electrons, and if we remove one electron, that time we will have a total 12 proton, 12 number of proton and 11 electrons in case of magnesium plus. But when we do magnesium 2 plus, that time we are removing both the electrons. This is also we are removing. So whenever we are removing both the electrons in case of magnesium, again this third shell is becoming vacant, 0. So that time we have 12 protons and 10 electrons. So we can see the number of proton is more, number of electron is less. So the attraction towards the nucleus for each electron will increase, and that decreases the size. So that's why cations are always in smaller size compared to their elements. You can see in case of lithium, the size is more compared to lithium plus. The sodium size is more compared to the sodium plus. Potassium size is more compared to potassium plus. And these are in given 10 to the minus 10 meter. Okay. So if you want to convert it into picometer, just multiply by 100. So this is 203 picometer and this is now 138 picometer. Similarly, in case of beryllium, we had 96 picometer size, but beryllium 2 plus is only 45 picometer. Magnesium 1.45 picometer and Mg2 plus is only 0.72 picometer. But in case of anions, let's see the case of anions. Anions having higher number of electrons experiences higher electrostatic repulsion. See, in case of anions, in case of fluorine, if you take fluorine, so we had this, I will draw here. This is the nucleus, this is the first shell, and this is the second shell. So in the first shell we had 2 electrons, and in the second shell we had 7 electrons in case of fluorine. But when we are putting one electron, so we are putting one more electron here to here in the orbit. So we are doing 7 plus 1. So one electron is increasing. Now we have 2 electrons in the first orbit and 8 electrons in the next orbit. So in case of fluorine minus, we have total 9 protons but 10 electrons. So we are putting one extra electron. That electron, so we already had several electrons. We already had 7 electrons, and then we are putting one more electron. So what will happen if we increase more number of students? There will be more chaos, right? More fight, more quarrel. So when we are adding one more electron, that time the electron-electron repulsion increases. And because of that electron-electron repulsion, these electrons will try to go away from each other. This will try to go this side, this will try to go this side. So that will actually expand this orbit size. So because of this, the size of fluorine is smaller, sorry, but the size of fluoride ion is actually much bigger because these electrons are trying to go away from each other. So as we are putting extra electron, the electron-electron repulsion is increasing. Those electrons are trying to go away from each other, and because of that, the shell is expanding, and we are getting higher value of radius, ionic radius or anionic radius, compared to the elemental form. You can see even in case of bromine, in the elemental form it was 120 picometer, but in the bromide form it is 196 picometer. And you can see the expand of iodine as well, from 139 picometer to 220 picometer. So we have understood that in case of cations, because we are removing electrons, so either the shell number of shell is decreasing or the electrostatic interaction is increasing. So both factors are reducing the size of the cations. It may happen that the shell is in decreasing, means earlier it was 3 shells. Now in case of sodium plus, there are only 2 shells. Similarly in case of magnesium, it had 3 shells, but in case of Mg2 plus, there are only 2 shells. Or even the shell number is same, but still if you remove electron, that will increase the electrostatic interaction. So because of that, the size of the cation is always smaller than the elemental form. And as we are putting extra electron, so that will increase the electron-electron repulsion. So because of that, the orbital or orbit will try to expand, and for that reason the size of anions are every time bigger than the elemental size or elemental radius, right? Next point is similar charge species along a group follows the same periodic trend as of the corresponding atoms. So the ionic radius trend follows exactly the same as the atomic radius trend. For example, we see in case of lithium, sodium and potassium, if we go from top to bottom, we can see the size is increasing, the atomic radius is increasing. Similarly, if we consider lithium plus, sodium plus and potassium plus, we can see here also the size is gradually increasing from lithium to potassium. And that is the thing, this ionic species, if it has same number of charge, that will every time follow the same periodic trend as of the elemental forms. So even if you take electron or give electron, if you convert in the ions, and if you convert in the same nature of ion, if it is 1 plus, you have to compare it with 1 plus charge. If it is 2 plus, you have to compare this with the 2 plus charge. So if you do so, you will have the same periodic trend as of the atomic radius trend. But yes, you cannot compare the lithium plus to fluorine minus, F minus, fluoride. These are not same charges. You can see here it is plus 1, here it is plus 1, and here it is minus 1. So you cannot compare those to take the periodic trend, or you cannot compare this plus 1 to plus 2. So these are not similar charge. If you have similar charge species, only then this rule will apply, and the ionic radius trend will exactly follow the atomic radius trend.
Hey genius, I hope you liked the video and the concepts are clear. So if you want to know more and if you want to learn more, you can go and check the periodic table and periodic trends folder. I have already uploaded 7 lectures on this topic. Please go and watch all those 7 lectures. I hope it will be very useful for you. And if you think these videos are knowledgeable, please share it with your friends and don't forget to subscribe. Okay? Thank you. Bye bye.